to pay attention to detail. The mathematics that you use in probability is real basic addition, subtraction, multiplication, and division. So you don't have to be an algebra or a trig scholar or a calculus scholar to make a good grade in probability and statistics. I would highly suggest that you mark this in your notebooks, because some of you may come back to take a Math 120 with me, and the first 2 units is chapter 12 and 11 in that order in Math 120. So some of you that may come back are taking my Math 120. In fact, I believe I'm teaching Math 120 next semester. I think I showed y'all that. And I think I'm teaching another one at 10 o'clock. I think I just found that out too. But this is the first 2 units. So if you need another math, you could take Math 120. Anyway, this is going to be a reading section. I think 12.1 is the reading. If you look, there's no numbers. See all those slides? There's no numbers. There's some toward the end, but after 12.1, you start to get into the math. Let me go ahead and map out what we're going to be doing in 12.1. In 12.1, you're going to do a lot of reading. And the reading that you're going to be doing in 12.1 is going to talk about statistics. And it's going to talk about a lot of definitions. Okay, so that's 12.1. 12.2 through 12.3 is where all the math is probably going to be. And we're going to talk about mean, median, mode, range, mid-range, variance, and standard deviation. And all that is basic mathematics with numbers, and it all revolves around the center. Okay, so if you go, and I'm going to go to the textbook right quick, and I'll come back to this in just a second. If you go to the eText and you pull up the table of contents for the eText, and you look up 12.2 through 12.3 or 12.4, I can't remember. What do we do? Will we go, let me look for the syllabus again. I think we go to 12.4. Yeah, well, there's right now. Sampling techniques and misuses of statistics. That's all reading. And then these 3 sections right here are all about the math and being around the center. Okay, so I did number it correctly. I thought I did. So when you talk about chapter 12, you're not talking about, talking about a lot of reading. And then 12.2 to 12.3, you're going to be talking about all this stuff. So 80% of your test is going to come from 12.2 to 12.3. And I might break this up into 2 tests. I don't know if I will or not. I'm probably will, but I don't know yet. I may just make it 1 test. So 80% of your test will come from 12.2 and 12.3 of this unit, and 20% will come from the definitions. Okay, so I'm going to go over some definitions first before we get into the slides. And the first definition that you need to be aware of is capital statistic versus lowercase statistic. When you see the word statistics, and it has a capital letter, okay, that means that you are studying the science of collecting, organizing, calculating, and interpreting data. Okay, so when you're talking about uppercase statistics, when you're talking about the capital S statistics, you're talking about the science with data. Okay, and when you're dealing with data, you're going to be dealing with the population, and the sample. Population is always the largest group. The sample is always the smallest group. Okay? So an idea of a sample would, a population would be all Tri-County Tech students. That would be a example of a population. And if I wanted to just study a sample, that would be like AC campus. Okay, the sample is always smaller. Now, why do you want to use a small sample instead of a population? Two things that are most important to everybody everywhere. What are the two things that's most important to everybody, every business, every individual? What's
Money.
two things that are most important to everybody?
Money.
Money and what? They usually go hand in hand. What goes in with money? Starts with a T. What's more important to you than money? Time. Time and money. Why is that most important? Because they go hand in hand. If you are in industry, the more time you take to make something, the more what? The more money it takes to make that something. And some people charge for their time, like a psychiatrist. The time that they spend, that's all they sell. They sell their time. In other words, you go see a psychiatrist or a consultant or a counselor, they are charging you per hour. So time is money. So that's the most important. So that's why you use a sample to save money and time to predict for the population. That's the whole goal of statistics, to take the sample and predict what's going to happen with the population. Now, in these two areas in statistics, we use formulas or equations. And those formulas or equations use variables. The variables in the population are called parameters. And parameters are usually Greek letters. Mu and sigma. are two letters that are used for the mean and the standard deviation. So when you see that mu or you see that sigma, sigma looks like an O with a pompadour on top. Okay? Then that means we're dealing with the population. If you're dealing with variables in the sample, you're dealing with lowercase statistics. Statistics. It's hard to spell. It's got too many T's in it. And those are going to be regular letters. For instance, X bar is the mean and S is the standard deviation for the sample. So that's the difference between uppercase statistics and lowercase statistics. And I'm going to do lowercase in orange. That's the lowercase statistic. So statistics in general is the science of collecting, organizing, calculating, and interpreting data. In statistics, you have the population and you have the sample. The sample is used to predict for the population. Formulas or equations that are used in the population and the sample have variables in them. Those variables are called lowercase statistics in the sample and parameters with the population. Parameters are usually Greek letters, mu, sigma. Statistics for the sample are usually regular letters, X bar and S. And you're going to see these later on. You're not going to see them right now, but you're going to see them later on. Now, there's a couple other things you need to know about statistics. What kind of things do we use? What kind of numbers are there? Well, there's two types of numbers in statistics. Then, first of all, what kind of information? First of all, there's qualitative data. And there is quantitative data. You need to write one word. Categorical, if that is a word. And for quantitative data, we're talking about meaningful numbers. Categorical data. Blondes, brunettes, redheads. Blue eyes, brown eyes, green eyes. Those are examples of categorical or qualitative data. Quantitative data would be age, finding the ages of everybody in the class. Shoe size, height, weight, shoe size. That's the difference between qualitative data and quantitative data. Qualitative data is put in categories. Quantitative data have meaningful numbers, like age, height, weight, shoe size. Those are 2 test questions, so make sure you know them. And they'll just give you an example. They'll say, what about the heights of a basketball team? Is that category? Is that quantitative data or qualitative? It's quantitative. It's heights. There's 2 types of numbers also. There is discrete data. And then there's continuous data. These are test questions. So far, everything I've gone over is test questions as far as 12.1. Discrete data is data that is or are countable. Continuous data is measured. So I want y'all to tell me something that's countable and something that's measurable. Let's go with countable first. Give me something out there in the real world that's countable.
Money.
Money is countable. What else? We're going to get at least 3 of y'all to talk today, so I'm just waiting.
Scores in a football game.
Okay, scores. Any type of score. What?
The people attending like an event.
Okay, I'm going to just say numbers. Let's say numbers attended. Okay, that's good. I'm going to give you something easier than that. Eggs.
That's pretty easy.
Yep, and that's pretty simple to remember. If you remember eggs, you remember that you can only do one thing with eggs, and that's count them. You can't measure them. You could measure them, but they'd all be about the same, but they wouldn't be the same. But you can do 2 things with eggs. You can crack them or you can count them. You can do with eggs. All right? Somebody tell me what you measure.
Water.
Volume.
Time.
Time. Come on, think of some everyday things that we talk about.
Distance.
Temperature.
Weight.
Oh yeah, weight too.
Yeah. What else?
Temperature.
Temperature. Okay. Temperature. Yeah. Temperature is measured. Volume, time. Okay, let's see if we got the basics. Okay, meters, liters, and grams. Okay, we got grams, meters, liters, and grams. So we got weight. We got volume for liters. What's meters? What is that?
Length.
Distance, which is length. So there's your examples of continuous data. How are they continuous? Well, let me just put it to you this way. If I put 3 buckets of eggs, and I put the same amount of eggs in each bucket, and I put them outside in the parking lot, and I tell 3 of y'all to go out there and count those eggs, one in each, but one person count the eggs in each bucket, or one person, one bucket. Will all of you come out, if each one has the same amount of eggs in them, will each one come back into the room and say that each one has the same amount in it? Yes. Unless you can't count, each will come back with the same amount of eggs. What if I ask you to go out and measure a fire hydrant? And measure the height of a fire hydrant? Well, some of y'all can't read a yardstick. Some of y'all can't read a measuring tape. So 2 or 3 of y'all are just going to say 2 or 3 foot. And then 2 or 3 of y'all are going to measure exactly to the nth degree. And then 2 or 3 of y'all are going to dig down below the pine needles and the mulch and find out where it's actually touching the metal pipe. And you go measure from the metal pipe up to the top. So if I send 9 of you out to get measurements of the height of the fire hydrant in the parking lot, how many answers am I going to get? I'm going to get 8 or 9 different answers. So I like to tell one word that goes with discrete. Concrete. What's one word that you can say about concrete? It's very solid. Okay? These numbers are solid. What about these numbers? I would say flexible. Why? Let me give you another example. I've only got, how many? I only got 2 females in here. Why does the scales at the doctor's office are always heavier than the scales in your bathroom?
They lie.
See? That's why you don't have concrete with scales. The scales that if you measure 120 pounds at your in your bathroom and you don't eat anything, you don't drink anything, and you go to the doctor's office and weigh, the doctor's office is going to say 125 pounds. That's why there's a difference between continuous and discrete data. Continuous is measured meters, liters, grams. I use that as an example because that's distance, that's volume, and that's weight. Anything that you measure is going to be flexible. Another example, how many times have you looked at a clock in one room and the clock in the other room says 5 or 10 minutes before or 5 or 10 minutes after? Again, it's time, it's measured. So that's the difference. So far, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 questions so far from 12.1. Or possible, you're only going to have a few, but to be out of these 9 that I'm asking so far. Okay, now I'm about tapped out as far as memory, so I'm going to go to the handy dandy 12.1 and let's see what they say, see what I've left out. Okay, all right. There. Statistics is the art and science of gathering, analyzing, and making inferences, predictions. Okay, we went over that. 2 main branches. Okay, I didn't go over this. Let's write that down. Descriptive statistics and inferential. Descriptive statistics, I'll give you one word, your test average. Write that down, test average. Because that is statistics based on numbers that you have. So put test average. Inferential is when you go out and get data. Like you go out and ask people, what's your favorite color? And you ask 500 people what their favorite color is. That's inferential. So that's the two types of statistics. Could be a test question. Now that is a standardized test question. Of course, the 9 that I've already went over, those are given standardized test questions. This would be more of a standardized test question than it would be my question on my test. Okay? But it could be a test question. More of a standardized test question. Okay? And when you write down these definitions, you don't have to write down word for word. Just write down, I would write down test scores, collection, organization, and analysis. In other words, basically you're organizing your test scores, you're adding them up, and you're dividing by how many tests you have, and that is your outcome. Okay? There's the word prediction in here. No, I cannot predict that I'm going to make an A when my test score says I'm going to make a B. Okay, in other words, you can't predict with descriptive statistics. It tells you what you have, your average. It tells you. Inferential is when you say, well, I've interviewed 500 people and the most common favorite color is red. So I predict that if I interview 5 more people, I'm going to get at least one person that's going to like red. That is a prediction. And that's the difference between inferential and descriptive. Descriptive just tells you the deal. You've got a B average. You've got an 82 average with your test scores. Boom, that's it. It gives you what you want. Inferential can predict by using data collected. Now I have my own definition of a statistician, so I better not share that. I always say a statistician is somebody who couldn't get a math degree, but I shouldn't say things like that. A statistician is only dealing with statistics, and I'm not going to hold you responsible for that. And a population consists of all items, so that's the biggest. The population is the biggest group. We already talked about population. That's why I hate reading these things. I feel like I'm boring everybody with going over definitions. A sample includes some. Sample is smaller than the population. When a statistician draws a conclusion from sample, there is always the possibility that the Mark Twain always said. I'm going to pull it up so that way you can see that he said it. I'm not making it up. There is lies, damn lies, and statistics. Lies, damn lies, and statistics. Somewhere there are 3 kinds of lies: lies, damn lies, and statistics. Mark Twain. So I didn't make that up. Okay. Now, what does that mean? It means that sometimes people lie using statistics. There are 3 types of lies. Lies, damn lies, and statistics. When you go to a big city, Who are you supposed to be weary of?
I need your consent on a few items.
Okay, I don't know why my phone is talking to me. When you go to a big city, let's say you go to New York, who are you told to watch out for? Con men, right? Why are con men, why you got to look out for con men when you go to a big city? Because that's where they hang out, okay? What do you have to be, what is it called when you are, what's the word I'm looking for? When you are acclimated to con artists on the street, what's that called? Being what wise? Oh, come on, people. When you are blank wise, when you are street wise, y'all not know any of this stuff, or y'all just meaning to be quiet just to aggravate me? Which one is it? Good gracious. All right. What is streetwise? What?
What was the question again?
I asked you, when you know what's going on the streets, and you are weary, and you know about the con men on the streets, or the con people that con you. What is that called? It's being blank wise.
Street smart.
Street smart, streetwise, yes. Okay. Now, what does streetwise and street smart have to do with this? Well, the more you know about statistics, the less you can be lied to with statistics. Okay. It's kind of like anything else. If I walk up to you and I tell you, Miss Hatton, I'm going to pick on Miss Hatton, I've got blah, 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 blah. And I tell you all this stuff, and you don't know me, then you either don't believe me or you believe me, one of the two. So the same way with statistics. If you don't know a person, when you're in a room full of people and the ones that are quiet, they're usually the ones that you have to watch out for, or the ones to believe, one of the two. The ones that run their mouth all the time, those are the ones you can just write off because they're full of bull crap. So that's part of being streetwise. You ever heard that before?
That's true.
Yep.
It is. I used to know a fella, he lived in Liberty. His name was Charlie Holcomb. And if he's still alive, I don't believe it. But he was old when I was a kid. And he always wore overalls, and they were always raggedy. And he always drove an old truck to the cow sale with an old beat up trailer. When that man died, he had at least 7 figures in the bank. Okay? The person that you think, the person that doesn't say anything, is usually the person that has the most. And the loudmouth is the one that has the least. So always remember that. Same thing with lies, damn lies, and statistics. If you know statistics, then you know when you're being conned. Okay? And I'm going to have to shut her down there because some of y'all are going to start convulsing. Well, we got a few minutes. Let me just look at the rest of the slides and see what the slides say. That's what that means right there. There's damn lies, there's lies, damn lies, and statistics. Random sample. The best thing to remember, you don't have to write all this. The best thing to write with a random sample, everyone has the same chance. Write that down. Everyone has the same chance. So if I put all y'all's names on a piece of paper and throw those pieces of paper in a goldfish bowl, and I scramble it around and shake it up and pick one name out of it, that is called a random sample. That's very important. That is a standardized test question, and it is also one of my questions. So I'm up to 10 or 11 questions now that I can pick from. And random sampling is a test question. Everyone has the same chance of being picked. Systematic sample, another good one. Systematic sample is when I have too many people. Let's say I have 100 people in my classroom. That's too many names to write down. So I'm going to pick every 10th person. That way I only have 10. Or I'm going to put everybody in groups, and I'm going to pick groups. Now the difference between groups and systematic, groups is called, and I'm going to write this down for you, a random sample is based on individual having equal chance. So if I put everybody's name in a fishbowl, there's 7 people in here, so 8 people in this class, and I put everybody's name in a fishbowl. I got 8 pieces of paper in a fishbowl, and I pick your names, one name, then that's a random sample. A simple random sample I take out the individual and I put group having an equal chance. Let's say I only have 3 pieces of paper. So I divide Brickman, Tillotson, and Searcy into a group, and I call them Group A. And I put their names on that piece of paper. And then I take Group B, the second piece of paper, and I put Bustos, Hubbard, and Hatton on that piece of paper. And then the third piece of paper I call Group C, and I put Henry and Christian in that piece of paper, on that piece of paper. And I put those 3 pieces of paper in a goldfish bowl, and I scramble them around, and I pick one of those 3 pieces. That's called a simple random sample. And a simple random sample is usually when you use some type of group, and each group has an equal chance of being picked. Now, what does that mean with systematic? With systematic, I pick every nth person. Systematic. Every nth person. Now, it's not a random sample because everybody doesn't have the same chance of being picked. But basically, I go through, let's say that I just decide to pick 3 people out of this group, and I put y'all in alphabetical order by last name, and I pick every 3rd person. So that would be a systematic random sample. Actually, it should be called a systematic sample because it's not random. Because I put you in order for one thing, and then I pick every 3rd person. So I'd pick the 3rd person, 1st person, the 4th person, and the 7th person, or something like that. If I don't start with the 1st person, then I go the 3rd person, the 6th person, the 9th person, the 12th person, and so on. Okay, so every nth person. Now those right there are the 3 best samples as far as being random. Why do we want to be random? We want to be random because we always, in statistics, what's our key word? We want to be what? I want somebody to say that word. if I spelled it right.
Neutral.
Neutral. Neutral means non-biased. Oh my goodness. Where does that word come from? Bias. What does bias mean?
Favoring one group.
Exactly. Favoring one group or one side or whatever the case may be. All right. In statistics, this is the good word. This is the bad word. Okay. And we're going to stop there at random. We're going to stop there. Let me check the roll. Let me turn off the recording.